here with another video on easy math. Today we are going to properties of logarithmic functions, as you can see. Here there are total of 13 properties listed in front of you. The first property is that log AB base E is equal to log A base E plus log B base E. Here base should be equal and there will be some conditions. Here the conditions are A comma B should be greater than 0. And the another thing, here base is a constant. If base is a variable, the base also should be greater than 0 and it should not be equal to 1 also. Now the second property. The second property is that log A by B base E is equal to log A base E minus log B base E. Here also the base should be equal with minus sign in between the two logarithms. Here the conditions are A comma B should be greater than 0 and if base is a variable, then it should also be greater than 0 and not equal to 1. Okay, now the third property. The third property is that log A power M base E is equal to M log A base E. Means the power comes before. The conditions are A should be greater than 0 and power should be real number, right? So M belongs to R. And the other thing, if base is a variable, it should be greater than 0 and not equal to 1, as always. Now the fourth property. The fourth property is that if there is a logarithm in the form log A base A, then the value of that will be 1. Here the conditions, as always, A should be greater than 0 and base is a variable, so A not equal to 1. Now the fifth property. The fifth property is that if there is power in the base, means log A base B power M is equal to 1 by M, means the reciprocal of the power log A base B. Okay, now what will be conditions here? A and B should be greater than 0 and B not equal to 1. And as always, M should be real number. But here another thing is that if M is 0, then the value of the base will become 1. Base should not be equal to 1. So M should not be value of 0 too. So M belongs to R minus set of 0. Now the sixth property. The sixth property is that if there is a logarithm log A base B, then it can also be written as 1 by log B base A. Okay, now here what will be the conditions? A comma B should be greater than 0 as always. Base should not be equal to 1, so A comma B not equal to 1. The seventh property. The seventh property is that if there is a logarithm of form log A base B, then it can also be written as the division of two logarithms, which are log A base M and log B base M. Here base should be equal. Okay, now as always the conditions are A, B and M should be greater than 0 and here B and M are bases. So B comma M should not be equal to 1. Okay, now the eighth property. The eighth property is that if there is logarithm in the power and the base of the whole exponent and the base of the logarithm are equal, means A power log M base A is equal to M. Now here always A should be greater than 0, A comma M should be greater than 0 and base should not be equal to 1. So A not equal to 1. Now the ninth property. The ninth property is that in this one too, there will be logarithm in the exponent. Means A power log B base C is equal to B power log A base C. Here the base remains same. Here the base of the logarithm remains same. Here as always A comma B comma C greater than 0 and base should not be equal to 1. C not equal to 1. And the 10th property, if there are two logarithms with same bases and one logarithm is greater than another logarithm, means log x base m is greater than log y base m, then x will be greater than y if m is greater than 1 and y will be greater than x, or x will be less than y if m is in between 0 and 1. Okay, now as always x comma m comma y greater than 0 and base should not be equal to 1, m not equal to 1. Okay, now the 11th property. The 11th property is that if there is a logarithm of value b, means log A base m with value b, then it can also be written as, or if we convert that into exponent form, it becomes A is equal to m power b. The base of the logarithm becomes the base of the exponent and the value of the logarithm will become the power. Okay, now here as always a comma m greater than 0 and base should not be equal to 1, m not equal to 1. Power should be real, b belongs to real numbers. Okay, what if we take off this equal to and we keep greater than or less than symbols? We'll understand them now. The 12th property is that if log a base m is greater than b, then a will be greater than m power b if m is greater than 1. A will be less than m power b if m is in between 0 and 1. So now the 13th and last property is that if log a base m is less than 0, then that implies that a is less than m power b if m is greater than 1. A is greater than m power b if m is in between 0 and 1. Okay, now let's discuss about trigonometric functions. Okay, the first function is sine function. Okay, as you can see, this is the sine function. This is periodic. Now here the domain of the sine function is R, as it extends from minus infinity to infinity, and the range of this function is minus 1 to 1, as it is extending from minus 1 to 1. Okay, now next let's take the cosine function. The domain of this function is, as you can see, minus infinity to infinity, which is nothing but R. The range of this function is it extends from 1 to minus 1. So the range of this function is minus 1, 1. As you can see, this is also periodic. Okay, now let's discuss about tangent. As you can see, this is the tangent function. This is also periodic. Okay, the domain of this function is R minus 2n plus 1 pi by 2. Odd pi by 2's. So 2n plus 1 pi by 2's. R minus 2n plus 1 pi by 2. Now the range of this function is, as you can see, it extends from minus infinity to infinity. So the range of this function is R. Okay, the next function is cosecant. This is the cosecant function. Okay, the domain of this function is all real values minus it does not exist at these dotted lines. These dotted lines are pi, 0, minus pi, 2 pi, so natural pi values. So the domain of this function is R minus n pi. Okay, now the range of this function is, as you can see, this starts from 1. This starts from 1 at the positive y-axis. It starts from minus 1 at the negative y-axis. So the range of this function is R minus set of points between 1 and minus 1. Okay, now let's take secant function. As you can see, this is the secant function. This is also periodic. The domain of this function is R minus it does not exist at odd pi by 2's. So the domain of this function is R minus 2n plus 1 pi by 2. Okay, now the range of this function is it starts from 1 in the positive y-axis. It starts from minus 1 in the negative y-axis. So the range of this function is R minus set of minus 1 comma 1. Okay, now let's discuss about cotangent function. Okay, this is the cotangent function. Okay, now as you can see, this is inverse of the tan function and this is also periodic, and the domain of this function is that it is possible at all x values except at pi, 0, minus pi, 2 pi, at integral pi values. So the domain of this function is R minus n pi. Okay, now what is the range of this function? As you can see, it extends from minus infinity to infinity. So the range of this function is R. If you like the video, hit that like button, smash the subscribe button, ring that bell icon, notifies you when I release a new video. If you have any notes, comment down below. I will answer them in the next video.